now, coming to you live from Rogers Arena, Pre-Calculus Math 11. Dance! 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 Today, Chapter 8.2, Solving Systems of Equations Algebraically. Last year when we looked at linear systems, we had two methods for algebraic solutions. We had the substitution method and the elimination method. And we're going to rely on the same methods this year. So first of all, solving by substitution. There's 5 simple steps here. Number 1, solve one of the equations for y, or whichever variable is linear. Substitute that value into the other equation so that y is completely replaced. Hence the name substitution. 3, solve that new equation for all possible x values. And once we've got every possible value for x, we use those calculated values to find the corresponding y values. Step 5, check your solutions as always and state the solutions. Let's look at an example. Solve by substitution. Y minus x squared plus 6x equals 13. Y plus 2x squared minus 12x equals negative 14. Isolate y in one of the two equations. I'll pick the first one. Y is equal to x squared minus 6x plus 13. All this stuff here that is equal to y, I'm going to take over here and put in place of y, which then gives me x squared minus 6x plus 13 plus 2x squared minus 12x equal to negative 14. And when I tidy this all up, I get 3x squared minus 18x minus 27 plus 27 equals 0. Divide everything by 3. X squared minus 6x plus 9 equals 0. I mean, I could solve the equation as it was, but why not factor out a 3 and get it simpler? Oh, speaking of factoring, this is going to factor quite nicely as x minus 3 all squared equal to 0, which means then that x is equal to 3. Now I want to take that and find the corresponding y values. So I'll come back up to this equation. Y is equal to 3 squared minus 6 times 3 plus 13. And that gives me 9 minus 18 plus 13. And that is equal to negative 9 plus 13, 4. So I have the point 3, 4. I should double check that back into both of the equations. I mean, I'm pretty sure it works on the first one. Let's just double check the second equation. Does 4 plus 2 times 3 squared minus 12 times 3 actually equal negative 14? That's 4 plus 18 minus 36 equal to negative 14. 4 plus 18 is 22. 22 minus 36 is negative 14. Yes, it checks, so this is the solution here. The second method of solving that we have is solving by elimination. In this case, we solve both equations for y, or you could have it for 2y. I just want the y variable on one side of the equal sign and everything else on the other side. And then, if you recall from last year, we multiply one or maybe both of the equations so that when they're added together vertically, the y variable is eliminated. And we get a brand new equation from that addition. We take that new equation and we solve it for all possible x values. Once we've got those x values, we go back, we find the corresponding y values, check, state solutions. Let's look at an example. Solve by elimination. X squared minus 3x equals y minus 1. X plus y equals 4. Okay, I'll rewrite the first equation as x squared minus 3x plus 1 equals y. I will rewrite the second equation as x minus 4 is equal to negative y. Well, if I add these as they are right now, y and negative y are just going to cancel each other out. So let's go ahead and do that. Notice also here that I lined up x directly with the other x, the constants with the constants, and there was no x squared term in the second equation, so I don't put anything directly underneath the x squared. But I always want to line things up with their own kind of terms. So x squared plus x plus 0x squared is x squared. Negative 3x plus x is negative 2x. 1 and negative 4 are going to combine to be negative 3. And that's going to be equal to 0y, which is simply 0, so I don't need to write the y. Although if you want to write oi, you certainly can. Finally here, let's factor this. This is going to go as x minus 3 and x plus 1, which will give me x is equal to 3 or x is equal to negative 1. So I've got those two solutions. Let's go back and get the corresponding y value. I think this equation will be easier to use. 3 plus y equals 4 tells me that y is equal to 1. Likewise, not 3. Likewise, negative 1 plus y equals 4 tells me that y equals 5. Check those back in the first equation. 3 squared minus 3 times 3, is this actually equal to 1 minus 1? Yes, it is. 0 equals 0. Check the second set of values then. Negative 1 and 5. So negative 1 squared minus 3 times negative 1. Does this equal y, which is now 5, minus 1. 1 squared, negative 1 squared is 1 plus 3 equal to 4. Yes, it is. Therefore, the solutions are 3 and 1 as one pair, and the other pair, negative 1 and 5. Just be careful that you're putting the appropriate x with its partner y value, right? This, when x was 3, gave us y equal to 1, and when x was negative 1, gave us y equals 5. So I have to pair them up appropriately over here. There we go. That's it. And now it's time for Two for You! Determine the values of m and n if 3, 4 is xy, the solution to a following system of equations. And then the second one, you have two unknown integers. Twice the large number increased by triple the smaller number is 46. Hey, wake up, wake up, wake up, wake up, wake up, wake up. Squaring the larger number, etc. What are the two integers? So much fun! Well, it's time for me to be heading out of here once again. Hope you learned a couple of things today. No, I sure did. Got any questions? Write them down, ask me in class. Until next time, keep your pencil sharp, and I'll see you in class. Get out of here.